The second part for hypothesis test for mu is when sigma is unknown. So when sigma is unknown, we call it as t-test. And the test statistic here we are using is t-stats, whereby it is x bar minus mu over s over square root of n. So the difference between here in z-test is we have sigma here and we have z-stats. But now we have t-stats and here is no longer sigma but it is s. So example of two-tailed test when sigma is unknown. The average cost of a hotel room in New York is said to be 168. So meaning that uh, we are claiming that the average cost is 168. And to make sure whether this claim is true or not, we take a random sample, 25 hotels, and from these 25 hotels, we got X bar is 172.5, and it said that S is 15.40, and we want to test the claim with alpha equals to 0.05. So we have all this information extracted from the question. So to solve this, we have this null and alternative hypothesis, which is our claim mu population mean is 168 and mu is not equals to 168, significance level, sample, and we have this degrees of freedom. So for t stats, we have degrees of freedom which is n minus 1. So here we have 24. And since sigma is unknown, so we need to use the t-stats, which is x bar. So we are replacing x bar minus mu over s over square root of n and calculate this and we get 1.46. So this is the test statistic and we need to compare with the critical value. So the critical value is from the t table, the t distribution table. So here we are looking at t degrees of freedom and alpha over 2 because it's a two-tailed test. So we need to divide alpha with 2. So 0.05 divided by 2 is 0.025. So 24, 0.025. So from the t table, we found it is 2.064. So this is the student t distribution, the t table. So this is the degrees of freedom, which is 24, and this is alpha over 2, which is the right tail here. So it's going to be 0.05 divided by 2. So we look at 0.025. So we found it is 2.064. So once we found it is 2.064, so this is the critical value, 2.064. So since it's symmetric and the middle is 0, so the left side is going to be the negative value. So here is going to be negative 2.064 and the blue shaded area is the rejection region. So here is alpha over 2, here is alpha over 2. So we have 2.064 minus 2.064 and we look at the test statistic which is the test statistic which is 1.46. So 1.46 is before this. So it falls in the acceptance region or do not reject H null or fail to reject H null. So that is the decision fail to reject H null because the t stats is less than the critical value. So meaning that since we fail to reject H null, conclusion is that there is enough statistical evidence that the average cost of a hotel room is equal to 168.